Welcome to another video and welcome to this tutorial. So in this tutorial we're going to be explaining the Cauchy theorems, and some can still call it Cauchy mean value theorems, and some can still call it extended mean value theorems. And how can we do this? So now the theorem says if f of x and g of x are both differentiable in an open interval this, and both are still continuous in a closed interval this, then there exists a point x equals to k, and this point must be a member of an open interval a comma b. So that we derive this formula for the extended mean value theorem. So that is f prime of k divided by g prime of k equals to f of b minus f of a divided by g of b minus g of a. So you observe that we have uniform function at the denominator and uniform function at the numerator. So where g prime of k is not equal to 0, otherwise undefined. That is, suppose I assume the value of f of k to be 2 and g of k to be 0. If it press 2 divided by 0 in calculator, so this is totally undefined. That is, in any value of g prime of x we get, it must not equal to 0, otherwise it is undefined. So if this is cleared, and let's see the beauty of this by considering one example. So find c, that is, find the constant value k. So here I use k, and we said there is a point x equals to k in the open interval a comma b. So now we want to find the value of that constant, which is c. I use a of Cauchy mean value theorem for the function f of x equals to this, and the second function, which is x squared minus x plus 25 in the interval 1 comma 2. So we must know something clearly here, that the extended mean value theorem, which is Cauchy, must have two functions, unlike ordinary mean value theorem, which has one function. So this one is defined on two different functions. Okay, so that is from the formula above, I use k, so I'm going to use c now. Since we're asked to calculate c, that is f prime of c divided by g prime of c equals to f of b minus f of a divided by g of b minus g of a. So here is the formula we are going to follow throughout the journey of this question. That is, all these 6 data, we are going to provide it in the two given functions and the interval. So suppose we have f of x equals to 3x squared plus 4x plus 5. And in this, we still have g of x, which is x raised to power of 2 minus x plus 25 are the two given function in extended mean value theorem with this closed interval 1 comma 2, and we know that this 1 comma 2 are both b and a. So where we have b to be 2 and a to be equals to 1, as the condition state, b must be greater than a. That is why b is 2 and a is our 1. All right, so now let's now decide to find all these 6 data, that is f of b, f of a, g of b, g of a. So using this interval b and a. So to start with f of b, so we have f of b, that is, it must be following the formula of f of x. That is, f of 2 equals to, in any value of these two we want to plug in, you must not mix it with g of x. So that is, we must substitute all this value throughout f of x for the first one. So here we have all this value that we plug in this, and the entire of this one is going to be equals to 3 times 4, that is 12 plus 13, that is 25. So similarly, we're also going to find f of a, that is f of 1. So we are still using same f of x, so which is 3 into bracket of 1 square plus 4 into bracket of 1 plus 5. And this equals to 3 multiplied by 1, and we have plus 4 plus 5. And everything here becomes 12. So And again, let's see g of b. That is, we'll be working with the function g of x now. We'll be putting the value of g of a and b in g of x. So let's see g of 2. G of 2 equals to 2 square minus 2 plus 25, as we are following x square minus x plus 25. So our a is 4 minus 2 plus 25, and everything here equals to 4 minus 2 is 2 plus 25, that is 27. And again, let's see g of a. G of a, that is g of 1, equals to 1 square minus 1 plus 25. And everything here equals to 1 square is 1 minus 1, 0, 0 plus 25, that is 25. And out of 6 datas, we have gotten 4. Okay, so we only need f prime of c and g prime of c. But before we can get these two, we need to apply the differentiation, because that prime, it means derivatives. Okay, and let's start. We have f of x equals to 3x squared plus 4x plus 5. And if we try to differentiate this, that is f prime of x is going to be equals to, if we differentiate 3x squared, we are going to get 6x plus, if we differentiate 4x, we get 4. Differentiating 5, we get 0. That is constant. And since it is c we are looking for, we just try to replace x with k or s with c that we are given here. So doing that, we have 6c plus 4. And if this is clear, so we call this one star. And again, let's see the g of x. G of x is giving us x raised to the power of 2 minus x plus 25. And differentiating this, we have g prime of x equals to differential of x squared, that is 2x. And differential of x is 1. Differential of 25 is 0. Again, g prime of c equals to 2c minus 1. I also start this. And so I will now recall from the formula, which is f prime of c divided by g prime of c equals to f of b minus f of a, all divided by g of b minus g of a. As all this has been provided, so we just try to be replacing them. And we know that g prime of c, which is equals to 2c minus 1, is not equals to 0 here. Then we have f prime of c is 6c plus 4 divided by g prime of c is 2c minus 1 equals to, while f of b, which is f of 2 that we got, is going to be 25, and f of 1, which is f of a, is 12. So by putting on these two values, f of b is 25 minus 12 divided by yg of b, which is g of a, and which is g of 2, and g of 1, which is g of a. Both are 27, 8, 25. Then we are going to have this as 27 minus 25. Then we can now proceed to find the value of c. So here we have 6c plus 4 divided by 2c minus 1 equals to, we have 25 minus 12, that is 13, and y this is 2. So getting this, the next thing we are going to do here is that we are going to cross multiply rather. If you cross multiply, then we have 2 multiplying 6c plus 4 equals to 13 will multiply 2c minus 1. We try to open the parentheses. So we have 2 times 6, that is 12c, plus 2 times 4, that is 8, equals to 13 times 2c, that is 26c, minus 13 times 1, that is 13. And by collecting the like terms, that is those with c, we take them, and those without any letter, we take them. So by taking 13 here, it becomes plus, and by taking 12c, it becomes negative. And here plus this, that is 21, equals to, subtracting these two again, we are going to have it as 14c. Okay, and since we are looking for c, we divide both sides by 14. We divide both sides by 14 throughout. This will cancel, and here we have c equals to, this, I can break this thing down into So if I break this, we are going to have this as 3 divided by 2, because 7 will go in 14 and 7 will also go in 21. 7 in 21 is 3, 7 in 14 is 2, and 3 divided by 2 is 1.5. All right. So this 1.5 is a member of 1, 2, as from this theorem, which has stated that there must be a constant value in the open interval 1, 2 that we just got now. I know between this interval we are going to see 1, 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 2, 2. So and since there is 1.5 there, then we can now conclude that the Cauchy mean value theorem is totally verified. All right, and it is always differentiable in this. And this is how to solve this. Thanks for watching, and don't forget to subscribe to this channel and turn on